Hello friends, welcome back to the bench. Thank you very much for joining me. And this is Alienware 17R4 motherboard. It is equipped with i7 CPU and 1070 GTX. Very nice little thing. The laptop, it's not a modern gaming laptop, or maybe not super new. It uses DDR4 memory. But it's perfectly fine. You can run whatever game you want on it, just not on the with high specs. Now with these, last time I made one of these, or I worked on one of these, we had some input from Dell parts people. He specializes in Dell devices, and before even watching my video, he said that, when you run it, the CPU is going to be fried, and when you run it, it's going to be, I don't remember, like two blue and one red, or two red, one blue. When you try running it, right, the LED is gonna be lighting up, indicating that the CPU is fried. It manifests by when you connect the charger turns off. Right, indicating a short on main power rail. Short on main power rail usually means that it's a shorted VRM on either CPU or GPU. And now the question is, on this board, is it going to be a CPU or GPU? If it's GPU, we're good, because I have another board with fried CPU. So if this one has fried GPU, and actually it doesn't have to be fried. That's actually, if the short is on GPU, it's really good, because GPU can take that hit, usually. CPU cannot. So if the CPU VRM is shorted, most likely our CPU is fried, which means this board is also relatively useless to me. But let's confirm that. So let's get rid of all these thermal pads and stuff. Expose the coils in there. So first thing here, this resistor, if I remember correctly, this resistor is for main power rail. So let's do the resistance continuity, and let's set, oh yeah, something's wrong with my multimeter disconnected again. Hang on, let me try and fix that. Okay, I don't know if it's my software that sucks or this multimeter that sucks. I rebooted the system. I checked in the code. It just times out. Right, there's like a fixed 2-second timeout. If the meter doesn't respond in 2 seconds, we just terminate. Right, and you have to connect again. It's basically for when you disconnect the cable, so we don't try and read the port. We just want to close the port, and if you connect it again, then start again. But it didn't help, and finally I just rebooted the meter, and now it's working. So I don't know if it's my software, if it's my system, Windows, or it's the meter. Anyways, let's go to the continuity, and let's put the threshold. I disconnected again. Oh, are you kidding me? Okay, I want a threshold at 3 ohms. Time out again, and it times out. Okay, we're supposed to be fixing the board, not the software, but yes, there was a bug. So if you're using this software, it doesn't work in continuity reading. So I'll try to have the fix published today. We'll see. Alrighty, let's do it again. So now this, as I said, probably is a main power rail, which is shorted, and it's showing 400 milliohms. 400 milliohms. That's a good news, actually. I mean, we'll see. Because I would expect lower if the CPU was shorted. But if the GPU VRM is shorted, the GPU resistance could be around 400 milliamps. Let's check on the CPU, on the core. Oh, this is so weird. It says open. No way. Yeah, 4.7 ohms. I think the CPU is good. It's still a little low. I would expect it to be closer to like... No, this is i7. Yeah, this could be good. Let's see, which one will be the memory? This is open. Oh, we're shorted here. What is this? Nah, we have 200, 300. Yeah, not good. Yeah, so no, the CPU is most likely dead. This, but it's weird that we don't have short over, yeah, on this one. But these, so this might be memory. Yeah, yeah, I think the CPU is dead. That is so 200 on GPU, also 200. So we don't know for sure yet, but 200, not good, not good. But as the specialist said, this is very common on these, that the CPU will be shorted. Let's see what the millimeter is gonna tell us. So this is on CPU, yeah, 200, way too low, and on GPU, 157. It's lower on GPU. That's a good news, but actually, yeah, that's a good news, because if we have a shorted VRM over here, the CPU might show short, but it's actually not shorted because it's shorting through GPU. So it could be that the GPU VRMs are shorted. So now let's check between the main power rail. This resistor here. I think this resistor supplies GPU. We have 500, and on the other side, so the side of the CPU, is 170. So based on that, I conclude that it's the CPU VRMs that are shorted. Yeah, 500 here. So it's shorting. So here it's shorting through GPU, CPU, and the shorted VRM over here. So I conclude one of these is shorted. So what we're gonna do is just confirm that and remove the shorted VRM and check the resistance on the CPU again, but based on what I see, the CPU is dead, which is too bad, but what are you gonna do? All right, we have the wire solder done. I used the caps over here, right, the positive and the coil. So we're expecting short on one of these 5 VRMs. Now we're gonna use 0.7 and I limit it to 100 milliamps. That probably won't be enough, but maybe we'll get lucky. Who knows? These are really hard to spot because they dissipate the heat really well into the board, not to the case. But let's see. We are grabbing, yeah, so it's dropping to 10 millivolts. It drops to 10 millivolts. So we might not be able to see that. Also the reflections and stuff. Yeah, once, oh, hang on. No, that was a reflection, okay. All right, so we can either increase the voltage or increase the current. 100 milliamps is very low. Let's do, especially at 0.7 volts, right? I'm gonna go to 500 milliamps, but it's not gonna grab all that, I think. So we'll see. I mean, as long as the short is where we expect it is, it's fine, right? Because the current will only flow from this point to this point, only putting a strain on one of these. But if you don't know where the short is, or you're not confident that you know where the short is, then be very careful with that, because the current will flow through the rest of the circuit, and it might fry some other stuff. 0.7 is, I would say, maximum voltage that you should use, but it kind of depends. So we're grabbing not even watt, not even 0.1 watt. Okay, I also made sure that I know where the short is. So I looked at the GPU and CPU. If you're connected like this, you can't find which one of these is shorted. Always check if the CPU or GPU are not warming up. If they are, that means the short is not here, the short is on the other side, and you're pushing current through both GPU and CPU. But that's not the case, so we can freely now increase. Let's increase the voltage to 1 volt. The actual voltage is not going to be 1 volt. Let's see what it's going to be. It's going to be 0.11, 0.12, 120 millivolts. So we don't have to worry about that. But as I said, we're pretty confident that the short is here on the VRMs, on the CPU. But it is invisible. I find it easier to find when I connect in reference to ground. But then you have to push some current through the CPU. And if you don't have to, it's better if you don't. There, okay. I see it. It's really tiny. It's really tiny, even at this power. And what is the power actually? Yeah, it's not even registering. It's not even 0.1 watt. So it's less than 100 milliwatts. But I see it over here. Yeah, it's so minute that it's very easy to miss. And it's definitely a top. It's definitely top transistor. This guy. So let's remove it from the circuit and confirm that the CPU is fried, unfortunately. And one way that you know that this is the one, if you try to desolder it and it lets loose easily, that's probably not the one. Normally, when I get these, when I start heating, both this one and this one are going to be flowing, are going to be moving, and this one is not. Everything, even coil, all those caps, everything here is going to be floating because of the heat. But this one won't, because it's kind of fused to the board. Now, I know some people do grinding and grind them off. I know it's time consuming, and I know it's a pain to do it with hot air alone, but I haven't seen a shorted component that fused to the board that I couldn't remove with just heat, nothing more. It takes a lot of it, sure, it takes some patience, it takes some time, but it's always, you can do it. There's no, I haven't seen the short that had to be grinded, that you had to grind to remove it. If that's easier, then sure, go ahead, go for it. But in my view, it is not easier. It's actually a lot harder, and you're risking damage to the board. So what we're gonna do over here is go to 460 degrees. We're gonna do 100 liters per minute, and we're gonna remove it. So first I'm gonna preheat the board a little. So I'm blowing from far away, just to preheat it, because we have a lot of metal around it. Obviously this whole area is going to be made to dissipate heat as well as it can. So even when it isn't shorted, it's still quite challenging to remove one of these, because there is a big plane underneath, and yeah, and it's kind of like MOSFETs, but like 3 times more difficult than removing MOSFETs, and removing MOSFETs can be also pretty challenging. Now I didn't cover the caps, so we'll see if they explode. They might. I can probably just do this, just to give them a little bit of, yeah, that'll drop a few degrees, the maximum temperature on the caps. But even if they explode, we don't care. They're easy to replace. I mean, as long as you don't get hurt. Right. Now you could use a little flux to speed this up. Probably, it usually lets loose easier when you put some flux, but that flux is going to be blown all across the board, and you're risking moving other components. I'm gonna get closer. It's only 100 out of 120, so yeah, it's obviously not moving yet, but now let me get a little close up on it. Okay, now there's not a lot of tiny components around it, so that's a lot easier. Sometimes there's plenty of tiny components all around it and like right next to it, which makes it so much more challenging. See, the coil is already flowing. Probably this one as well. No, this one is holding. This one's probably flowing. No, this one is holding too. So we're far from the temperature yet. Yeah, don't use other components as a leverage point, because they will. Oh, this one's holding. No, this one's also flowing already. Yeah, and this one definitely. Now let's get pretty close. The solder around it is, it's not as hot yet. It should be completely liquid before the chip lets loose. Now, could you use the preheater to help with this? Sure, it's just a matter of time. I mean, you're not saving much time with preheater, because with preheater you also have to wait for the board to preheat. Right, so time-wise it's pretty much the same, if not longer, because you also have to set it up on the preheater, and a big chunk of the board is gonna heat up. But enough patience, and as you can see, it can be done without preheater. So again, if you wanna go to the grinding route and just grind it off, sure, if you can do it. But in my view, it's more challenging to grind it off than to just plainly desolder it. Now I'm gonna wick it just a little bit, just in case there are some bridges or something. I don't need it super clean, just enough, remove enough solder so we don't see any potential bridges, because I don't think we're gonna be replacing this if the CPU is dead on it, and so far everything points to CPU being dead. This is not the best tip for wicking. Actually, it's the worst tip for wicking, but it should be good enough. I just want to make sure there are no bridges, nothing more. It's not ready for the replacement. I would clean it a lot better if I was replacing the RM, because if you don't clean it well, it's hard to align the chip. It's hard to put it in place, because it's going to be waving and tilting and that kind of stuff. So the better you clean the board, the easier it'll be to replace the component. But there definitely no bridges. Also, wicking is a lot easier when the board is hot. It's a lot harder when the board is cold. Then if you can't wick when the board is cold, then you need to treat it with some hot air to heat up the board and then wick. Otherwise, it's a frustrating process, especially when the wick is catching the board and it gets stuck. If you lose your patience, pull too hard, you can pull the pad, and you don't want to do that. All right, it is nice and hot, but now we can just see if the short is gone. It should be there. So the short is gone to the point that it's open. Now the main power rail, let's check that resistor again in reference to ground, and the short is gone. Right, we are open here. It says open because I'm in continuity mode, so it's not going to tell us the exact resistance, and the range is heavily limited. So this was the problem, but let's check the CPU again, but it should be still shorted, because why wouldn't it? Yeah, because now it's hot. The CPU is warm now, so it's saying 100 milliamps. Here 1.5, right? It was like 4, was 4.5 or 4.2, something like that. Now it's 1.5, 1.6, because the CPU is hot. It's very hot. But that also means that the CPU is a piece of wire now. Let's let it cool down for a second and check the resistance once it cools down. All right, it cooled down to, well, enough. It's warm. It's not hot anymore, but it is slightly warm still. Now the resistance is 3.4. Actually, let's go to. Oh yeah, I really need to fix myself, because now it's not saying. It says the range is 500, but it doesn't say what unit it is using. Yeah, there are still a few quirks I gotta figure out around this software. And this one is, what, 3K on this one? What am I touching here? Yeah, 290 milliamps. And on this one, yep, 300 milliamps. Yeah, it's definitely too low. Yeah, we don't even need to check on with the millimeter. We know it's crap. Now let's see. The GPU should have, what, around 400, I think. It's closer to 200, 180 milliamps, which probably is fine. This is 1070, was it? Yeah, 1070. So yeah, this is probably fine. And those, you know, since we didn't have a short here, right? I don't expect GPU to be faulty either way, but GPUs can take some hits. They can survive a lot. CPUs, especially those Intel CPUs, are very vulnerable to, you know, sending 19 volts to them, obviously. What are you gonna do? So this board is LA-D751P, right? And if you see this board faulty on eBay, and it says that the computer turns off when you, or the charger turns off when you connect it, it's almost always the VRM on the CPU, and so far always the CPU is going to be fried. So I purchased this board for roughly $100. I think it was a little below $100. The guy wanted like $300 for it or something like that. There's no way you should pay $300 for this board. The only usable things that you get from it, other than like MOSFETs and stuff like that, would be the EC chip. They can go short, and I'm not sure if you need to program it, or you can just swap it from the exact same board. And that's pretty much it, because all the rest, you know, if you have a shorted transistor on the board you're repairing, then you want to replace it with the new one. You don't want to take it off the donor board. You only take specialized chips off the donor board. So perhaps memory, if your GPU suffers from, you know, memory issues, one of the chips is memory chips is faulty. Sure, you can grab it from here, but still you can buy a new one. So there's really no value in this board other than the working board. So these two components, CPU and GPU, need to be working. Everything else on it, even a C chip, although it's a pain, it's a pain. But even EC is it's fixable. It's fine. But CPU, it's not that that we can replace CPUs, no problem. And this is a tiny one. You don't even need the BGA station for this one. You could replace it with just hot air. You don't need a preheater. but you can replace it with just hot air. It is sizable, but not huge. So this is really easy. But you need a replacement CPU, and I keep looking for those CPUs and I can't find them. So I can only find faulty boards, but every faulty board has the same exact issue. Shorted VRM and shorted CPU. Every single one. So I'm gonna give up on that computer, on trying to fix that computer, because of lack of parts. And it's not like it's for the customer, right? It's just like a practice board kind of thing, you know. But still, it's pointless just throwing money into this repair and getting the same results. Well, that's it. I'm gonna be, yeah. I think I will keep looking around. If I find a board with different description of the issue, so I don't know, perhaps you plug it in and it just doesn't post or something like that, yeah, then I'll get it. But if there's no description of what the issue is, or the description says that as soon as you connect the power it dies, then definitely I'm not gonna try it, and I don't recommend getting these, because there's really very little value on these boards, unless you really, you know, don't have access to, you know, or don't know how to find the replacement parts, because sometimes it's not easy, and it is easier when you just grab, you know, this is faulty, so you just remove it from this board and grab it from another board and replace it, and it works. Then yeah, sure, that's a lot easier. But other than that, it's unreliable. I would say no, don't replace. You know, I know a lot of people do it. Sure, even with caps and transistors and stuff like that. But I don't like doing that. I think that if you're repairing stuff, you should replace it with the new one, and usually you can find it. Alrighty, this is it. Our piece of trash, not repaired, and I don't think we'll ever have any success with these if the fault is exactly the same on all of them. But that's how you get better. I hope you at least found it useful to see how to remove, or how long does it take to remove this VRM. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.